You are listening to The Vocal Technologist. Spoken tech for your ears.
You know, it really feels like the entire ground beneath software engineering is just completely shifted in the last 6 months.
Oh, absolutely.
If you're like me, you're probably feeling it too. The speed is just dizzying, and honestly, trying to figure out what still matters, what knowledge still holds up, it can be a bit overwhelming.
It's not about just knowing how to code anymore.
Not at all. It feels like it's more about, can you effectively manage the intelligence that's doing the coding for you?
Exactly.
So today, we're going to try and cut through some of that information overload. Our whole mission here is to really analyze the 3 biggest shifts that are, I think, fundamentally reshaping the day-to-day for a modern engineer.
A high-stakes reevaluation, for sure.
Yeah. We're talking about how AI has basically changed the job description, why quality control is suddenly the new bottleneck, and then what are the essential new features you actually need to know in web dev and systems architecture to, well, stay relevant. Welcome back to this specialized technical exploration.
Great to be here.
It's time to unpack the new normal. You're listening to The Vocal Technologist.
So where do we start? The big one.
Let's start with the big existential question. AI has made generating code incredibly cheap. Instantaneous even. So, what is the core job of the human engineer now?
Well, the center of gravity has shifted entirely. I mean, the challenge is no longer the mechanics of it, the actual writing of the code. That part's becoming automated.
Right.
The real engineering challenge now is it's all about defining the intent, the constraints, the trade-offs. The machine is a phenomenal tool for implementation, but only the human can really, design the system and articulate the nuances that a business actually needs.
That immediately puts all the focus on communication, on high-level design.
It has to.
So if the human's job is defining intent, then the documentation around that intent, it has to be radically better than what we're used to.
It must. And this is where, a seemingly minor thing suddenly becomes critical infrastructure.
Okay.
The humble pull request description.
The PR description.
Exactly. Because the core work is defining requirements, that PR can't just be a list of file changes anymore. It is the artifact. It's the thing that communicates the human's design to everyone else.
So what does a good one, a mission-critical one, actually look like now? Who are you even writing it for?
It needs to talk to 3 different audiences, really. First, it has to convey the executive intent. What business goal does this code actually solve?
Okay, the why.
The why. Second, it needs reviewer guidance. What specific tricky areas need a humie's eyes on them, especially since, parts were AI generated. And third, and this is probably the most important, provenance.
Provenance.
Yeah, which parts were written by the human designer and which were generated by an agent. If you can't communicate that context, you can't really do the job anymore.
Context is the work. That's a powerful idea. Now, I've heard this term, shipping at inference speed. It sounds, frankly, like a recipe for burnout.
For some people, it's reality. Their bottleneck is literally the AI's processing time, not how fast they can type. But you're right, that speed is introducing some real psychological friction.
I do want to talk about that friction, the grief. It's such a valid emotion, and I think it gets overlooked in all the hype.
It's a genuine sense of loss. I mean, think about it. Developers spend years, sometimes decades, mastering a craft.
The clever optimizations, the deep compiler knowledge.
Exactly. That beautiful, efficient algorithm. And when an AI agent can just replicate that instantly, it diminishes that personal satisfaction. It's a challenge to your whole identity as a creator.
It's almost like being demoted from a craftsman to a curator. How do you even process that without feeling, irrelevant?
Well, the best advice I've seen centers on a delegation strategy. We saw this great analysis from a veteran C programmer.
Oh, yeah?
He found the best way forward was to treat AI agents like skilled interns.
Skilled interns, I like that.
You delegate the specific tedious tasks, the boilerplate, the complex refactoring of a known pattern, while the human refocuses on the high-level intellectual work, the foundational design, the architectural analysis, the really critical optimizations.
So you keep the cerebral stuff and offload the drudgery.
Pretty much.
But that speed, that instant code, it leads us right into this massive quality problem.
Yeah.
I mean, how is verification even keeping up?
It's not. It simply isn't. Verification is the new critical bottleneck, precisely because the speed of generation has just, it's completely outpaced our human ability to check the work.
And the data on this is genuinely alarming. We're not talking about a small dip in quality here.
We have to face the hard facts. We're seeing reports that over 30% of senior developers admit they're shipping code that is mostly AI generated.
And that code.
And that code contains 75% more logic errors.
85.
And 45% more security flaws than code written entirely by a human.
Wow. Okay, 75% more logic errors. That means 3 out of 4 times the machine is subtly wrong. So how do you even adjust your review process for that? Are we just spending all the time we saved on manually auditing every single line?
That's the critical question, isn't it? And it's made worse by how sophisticated the failures are now. We're not just dealing with loud crashing errors anymore.
Right.
The newer, more capable models are showing what some are calling silent but deadly failures. The code runs, no errors, but it generates subtly incorrect results. Maybe it skipped a safety check or used a plausible but totally fabricated data set. You can't just trust the green checkmark anymore.
So the safety nets, they have to be built at the same scale. If I'm trying to move that inference speed, what's my absolute must-have?
It demands an absolute total reliance on automated testing. For that developer trying to move fast, we're seeing that over 70% automated test coverage is becoming the baseline.
Over 70%.
It's the only safety net strong enough to counterbalance the unreliability of that quick AI output. But wait, doesn't requiring 70% coverage doesn't that just replace time spent writing code with time spent writing tests? Are you really gaining anything?
That's a fair point. But the difference is that writing a highly constrained, predictable test, defining the acceptance criteria, that's a fundamentally different and often easier task than writing the implementation itself.
Okay.
And besides, writing the test is often a task you can delegate right back to the AI agent as long as you, the human, write that first correct high-level requirement for the test. You define the contract, the AI implements both sides.
Speaking of contracts and reliability, this has to be why we're seeing this huge renewed push for typed languages.
Absolutely. The risk from unreliable AI code is directly pushing developers back to systems that impose some structure. Typed languages, especially TypeScript, are booming because that type system gives you a foundational layer of reliability. It catches errors the AI missed.
Errors that might have only shown up at runtime?
Exactly, when it's much more expensive to fix. So beyond just the quality of a single component, there's the whole system.
Yeah.
When I'm moving at light speed, I'm probably just vibe coding, not really planning. That's the architecture trap, right?
Yes. Vibe coding without system design leads to what we call accidental architecture.
Like a digital Jenga tower.
A perfect analogy. AI prioritizes the immediate task, solve this ticket now. And that often results in, hard-coded values, minimal testing, a really fragile structure that just accumulates technical debt like crazy. It holds up until it doesn't.
And then the whole thing collapses.
Yeah.
So what's the antidote? How do you avoid building these fragile, accidental systems?
It's the conscious application of systems thinking and product management discipline, really. We have to double down on the core principles of DevOps. You have to design for change, not just for function. You have to consider the whole flow. If developers stop thinking that way because the AI is spitting out code so fast, we risk severe fragility and knowledge rot across the entire industry.
Let's talk about existing fragility for a second. Because we're creating new flaws, sure. But what about the ones that have been hiding in our systems for years?
Oh, that's a profound problem. The life cycle of the ancient bug. There was this huge analysis of over 125,000 Linux kernel bugs, and it came back with a really sobering number.
That was
The average bug lifetime was 2.1 years.
2 years.
2 years on average of silent, hidden technical debt. Some of the really complex race conditions were hiding in there for over 5 years before anyone found them.
That is a long time for a ghost to hide in the machine. Are we building better Ghostbusters?
We are, and we're using AI to fight fire with fire. There's a new tool called Vulnbert that really showcases this. It combines neural pattern recognition with 51 handcrafted code features.
So it's looking for specific patterns.
Exactly. Things like variable usage, pointer manipulation, control flow, and it uses that to predict bug-introducing commits. The recall rate is incredible, something like 92.2%. It's proof that AI, when you aim it at analysis instead of just generation, can help solve the very problems it's creating.
That's a fantastic transition. Let's pivot to some of the specific technical knowledge developers need right now, maybe starting on the front end. We're seeing this counter movement called anti-frameworkism.
Yes, This is one of the most interesting trends in web dev. Anti-frameworkism is basically this practice of encouraging developers to start projects with native browser APIs, modern CSS, web components, the Fetch API, instead of just defaulting to a heavy framework like React.
But for a decade, frameworks were the answer to everything. Why are people now saying, maybe we don't need all that?
Because the browsers themselves have matured so dramatically. They now natively handle most of the thorny issues that frameworks were built to solve in the first place. Component encapsulation, state management, dynamic styling.
The browser can just do it now.
For a lot of standard projects, yeah. The framework overhead, the bundle size, the hydration problems, the learning curve, it's often just unnecessary baggage that actually slows you down.
So the knowledge requirement shifts back to just pure web standards. Okay, let's get into some specific facts for CSS. What new capabilities should people be learning right now?
Okay, a few really powerful ones. Developers absolutely need to know about two new functions: sibling index and sibling count.
Okay.
These let you create really complex, staggered animations or layouts based entirely on an element's position relative to its siblings. All in CSS, no JavaScript required.
That's huge.
Yeah.
That used to require querying the DOM in JavaScript, which was slow and could cause flashes.
It's a massive shift in what styling can do. And there's also the new @container scroll state. This lets you query the scroll state inside a specific container as an element stuck as it's snapped. You can style based on that, which opens up all kinds of new UI possibilities.
So giving CSS access to container physics, basically.
Essentially. And one more key one, the new typed @tree function. This lets you pull HTML attributes directly into your CSS, but with type checking and fallbacks. So it adds some much-needed reliability when you're styling based on dynamic data.
Okay, let's move from the front end to the back end, specifically distributed systems. When everything is asynchronous, how do you even guarantee consistency without synchronized clocks, which we know are notoriously unreliable?
That fragility is exactly why we need ways of reasoning about safety that don't depend on perfect time, and that's where the sauna algorithm metaphor comes in.
The Sauna algorithm. Okay, I'm picturing people coming and going. Help me connect that to system consistency.
It's the perfect analogy for causality. In a sauna, you don't need a perfectly synced clock with everyone else to know that one event happened after another. You know it because of causal relationships, the happen before principle.
Okay.
If you see someone enter, then you see them leave, and then you enter, you know the order of those actions relative to you. You don't need a global timestamp. In a distributed system, a node guarantees consistency by relying on the message it receives, the happen before action, not by waiting for a global time signature that might never come.
So it's causality, not coordination. That makes it much more accessible. Okay, finally, let's spotlight a couple of new tools designed for this new AI-driven world.
Two great examples for smarter code search. For external context, there's RepoGrep. It's an ultra-fast AI coding agent for searching across any public GitHub repo. You need to see how the top 3 libraries handle some obscure edge case. RepoGrep gets you that context in seconds.
And what about for your own internal code?
That's Mantic. Mantic is a structural code search engine built for AI agents that runs locally. It gives you sub 500 meters file ranking across massive code bases. And crucially, it infers your intent from the file structure and metadata, which means you need to use far fewer tokens in your prompts.
Why does that matter to the engineer working locally? Fewer tokens.
Because fewer tokens means it's cheaper and faster to run your AI agent integrations. It's all about efficiency.
Okay, we have covered a huge amount of ground here, from the grief of lost craftsmanship to new CSS functions.
And the through line is pretty clear, isn't it? The developer's role is morphing. We're shifting from being low-level implementers to high-level conductors, managers of immense complexity.
The job is defining the intent and providing the judgment that the agent just can't.
Right. Technical competence is no longer about output volume. It's about verification quality.
It seems like AI makes all the easy things instantaneous. But the truly hard things, architecting robust systems, verifying subtle logic errors, making that final product decision, they're now more valuable and maybe more difficult than ever.
That tension is exactly where all the engineering value is going to live from now on.
So here's the final thought for you to chew on this week. AI makes exploration cheap, but it does not make decisions easy. You can now generate 1,000 different options in an hour, but the ultimate enduring value of a developer is the human judgment required to select the one idea that actually works best technically and for the product, from that massive fire hose of choices. The ability to verify and decide, that's the real power now.
An excellent point to end on. It puts the accountability for the final outcome firmly back on the human designer.
Thanks for joining us for this exploration of the current software landscape. We'll catch you next time.
Spoken Tech for your ears.